Hi, I'm Arielle Johnsson, and I work for Noma, which is a restaurant that you may have heard of in nearby Copenhagen. We get a lot of attention, and that's allowed us to start a nonprofit called MAD, which, for those of you that speak Danish, is a funny pun because MAD means food, and we work on food. And if you didn't get that pun, now you know some Danish. So I'm going to talk to you today about flavor because I think the future of food is going to be about flavor. And I think it's probably fair to define what we mean when we say flavor. So flavor, as we already learned from Charles, is a multi-sensory experience. The main contributors to it are our senses of smell and taste. We also integrate information from sight, hearing, and touch as well. So flavor is this perceptual construct that we experience in the brain. So the largest, probably, part of flavor, and probably the most complex, is smell. And humans have a physiology where we experience two types of smelling or olfaction. One of these is sort of regular olfaction that's called orthonasal olfaction. This is when you sniff a flower or something else, you smell it, you identify it as smell. Something a bit more interesting is called retronasal olfaction. In this type of smelling, we have, for example, a piece of food in our mouths, and the volatile molecules from that go up the back of our throats. Oops. There's the food, the volatiles go like that, and bind to this olfactory epithelium in our nasal cavity. So it's the same hardware as for orthonasal olfaction, but this one we experience as smelling, this one we experience as flavor. And so to put this into context, the hardware that makes up the olfactory receptors in our olfactory epithelium, these are the proteins that bind with the molecules that we're smelling, that we experience during flavor, and that let us actually have that as a sensory experience. The genetic code for that is part of a superfamily of genes that makes up about 2% of our genome. So that's actually the largest family of genes that we have that's devoted to smelling. And to put that into context, that's approximately the same magnitude of genetic information as separates humans from chimpanzees. So it's this huge amount of information conserved over millions of years of evolution just so that we can experience flavor. And when you look at where the molecules that that are responsible for flavor come from, these come from animals, they come from plants, they come from chemical reactions, they come from microbes, but also interactions between these things. So a plant that grows in a hotter climate will have a different flavor than the same plant grown in a cooler climate. The diet of a particular animal will affect its flavor when we eat it. The particular microbes that grow in wine or in sauerkraut or some other fermented food will produce different flavors depending on what other species are around them, what temperature they're in, what the humidity is. Basically, what I'm getting at is that there are these very complex ecological and biological systems and interactions going on all the time around us. And the products of those are things that we experience as flavor. So flavor you can look at as our intuitive system for interacting with these complex systems and finding things to feed ourselves with. So, I mean, you can think of flavor as sitting at this sort of confluence of cooking, science, tradition, ecology, technology, intuition, evolution, lots of different things. It's very much a linchpin of many things that affect our modern lives. So, as I said before, I think the future of food is flavor. I think it's important to point out that you could also argue that the past of food is flavor. The flavor industry has been a thing for approximately 60 years or so. The scale of which now is about $25 billion a year, making flavors that go into Coca-Cola, vitamin water, Doritos, candy bars, etc. So you might say, like, why would we want to be involved with that? I might turn that on its head and say, given that we have this amazing sensory system, why not put that knowledge in the hands of people that can do really creative and exciting things with it? So that is actually what I work on. This is where I work. Looks a bit like a doomsday prepper's bunker. This is a laboratory that we built in the back of Restaurant Noma in Copenhagen. So if you finish your 14-course dinner and go on a kitchen tour and go back past the grill section by the bicycles, you'll find this, and you'll find me there. And what we're trying to do here is we have me, who is a scientist, and several of the chefs in the restaurant working in an intentionally very integrated and anti-disciplinary way. So rather than me being off in an academic laboratory and them being in their kitchen, we've kind of mashed the two together for the purposes of experimenting with and investigating and trying to push the boundaries of flavor. We've had almost no budget to do this, so for those of you that are in fields that are interested in research and R&D but have no budget for it, I sympathize, because we also have no budget. So we've had to build everything ourselves. It looks like that because it's 4 shipping containers that we've modified. We do a lot of fermentation, so we've had to build our own environmental control system for that. These are temperature controllers that we've wired. This room is held at a temperature that's good for making vinegar. This one is good for aging miso in. This one we keep quite warm, so like 40 Celsius, so we can do a lot of like interesting, really rotted stuff. So, you know, we take this quite scrappy approach to what we do because we have to, and we have 2 directives. On the one hand, to take this kitchen knowledge and wisdom and intuition and turn it into research questions, and then on a sort of faster and more practical level, to get the most flavor possible out of an intentionally limited biosphere and source of ingredients. So if you're not familiar with Restaurant Noma, the kind of creative principle behind the menu is that the ingredients have to come from the Nordic region. So that's sorry, I keep hitting next. This area. And for those of you that are from around here, you know that we don't really grow citrus fruits or a lot of different types of vegetables and other things that you might like to cook with. So by having this space where we can work with transforming ingredients through fermentation and extracting them, isolating them, doing different techniques, these are some of the products that we get from it. We get oils, we work with seaweeds, other weeds, insects even, and basically anything we can work on to try to have the most flavor possible. And so like in the course of developing this type of cuisine, I think it's important to acknowledge like how this is possible. Where did it come from? So you may have heard of molecular gastronomy. This is the great chefs like Heston Blumenthal, Ferran Adrià, other people like that who really pioneered the idea of putting research into the kitchen and becoming masters often of texture and visual experiences. And what you see now at places like Noma, but many, many other restaurants, are plates that come out looking perhaps more naturalistic or less conceptual than some of these ones that came before, but a very serious internalization of this research ethos, but attached very much to the back end of this. So to push cuisine forward, chefs are becoming autodidact researchers and scientists, teaching themselves biochemistry and history, ethnobotany, microbiology, chemistry, all kinds of fields that never really had a cemented place in the kitchen before. So as a sort of takeaway beyond what, 100 people a day, which is what we serve, can use this for, I think one of the things that's really exciting and that we'll get to in the future is that the really good work on food, whether it's in the academy or in technology or in other disruptive things, is going to be in blurring the line between the kitchen and the lab and kind of moving away from only working with one type of knowledge. So one example of this that we work with is dealing with food waste. So there's an immense global food waste problem that I'm sure you guys have heard about. But it's also a problem in individual kitchens, whether it's your home kitchen or the kitchen at the restaurant. But by thinking a little bit like a chef, so looking for flavors and opportunities, and a little bit like a scientist by analyzing what the composition of some of these food waste items that we come up with are, we can actually turn a problem into an opportunity. So we have things like squid scraps, leftover bread, vegetable tops, and we sometimes make compost out of this, but by putting squid scraps, for example, which are a very rich source of protein, through some of our fermentation processes, we're able to make an extremely delicious fish sauce out of them. And bread, in a similar way, can become soy sauce, and vegetables can become vinegar or kombucha. So by using like a little bit of new know-how and kitchen intuition, we're able to make these really delicious things out of stuff that we were going to throw away. And there's no reason why only we have to do that. It's knowledge that any kitchen could use, which is really exciting. Kitchen or startup, or talk to me afterwards if you want to hear my pitch. So like one other takeaway is that, so I'm a scientist, I work at a restaurant, not at a university currently. And a lot of institutions, whether it is academic institutions or technology or some of these other communities, can be quite gatekept for people who don't have a formal training in this type of stuff. But I think one really exciting thing about where food is going is that almost doesn't matter, because people on the ground, whether it's chefs or farmers or small producers, are teaching themselves what they need to know to get it done. So the biggest takeaway, I think, with flavor is that it presents this opportunity for anyone who's working at a high level to kind of wade into this culture and learn a lot and kind of investigate these spaces between disciplines where we can make things that are really, really delicious. So for those of you that are interested in sort of disrupting your own way of thinking, there's a lot that can be done just by a little bit of mix of intuition and science. So I think that's my time, and thanks for listening.
Thank you.